Good morning class. Welcome for today's science class in 7th. I hope you all are fine. We are on the chapter heat and its effect, chapter number 4. Beta, what is heat? Let me introduce you. We are standing in the sunlight. When we sit near the fire or we take a piece of ice in our hands, what we feel? We feel some temperature, right? So, heat is a sensation, hotness or coldness. So, this is heat. Heat is a form of energy that can never be destroyed. It can be changed from one form to another. It can be converted to one form to the another. Okay, more things I like to discuss with you is this heat, what we are using for our daily household purposes, such as we are cooking the food. Without the help of heat, we can't do that. Running of the cars, running of the automobiles, all these things can't be do without the help of heat. Yes, the heat are converted into further processes. As we are running the car, you see, we are using the fuel coal, right? We are using the fuel petrol. Early days in engines, in railway engines, coal is used. And nowadays petrol, diesel is used in our vehicles. So what it used to be when the petrol was burned, heat changes to mechanical energy, which pushes the piston and the car used to move it. Again, in the electricity form, you can see when you switch on the button, electricity passes on and the fans start moving. It changes to mechanical energy. When you are ironing the clothes, you on the electric plugs, and what will happen? The iron become hot and we use it for ironing our clothes. So it's again heat that is transferred from one form to another. Okay, now we'll continue with this. Heat causes expansion in solids. Okay, let me introduce one more thing before this expansion word. I'll tell you what is expansion before going this solid. Expansion means the molecules are expanding, means the volume become increased or high. How? Take a beaker, right? Put the water in it, start boiling. After some time, what will happen? It will start boiling vigorously and the volume will increase, isn't it? And bubbles will start coming out of that container. After some time, then put a lid on it. When you put a lid on it, definitely that water which is coming out of it will pushes it. Okay, and after it the volume will start decreasing. Why? Because the lid you have kept will help it to condense. Right? The molecules start condensing and it will come up, down again. So the state changes. Liquid changes to gas and then gas again changes to liquid. State changes there. The volume increased and decreased. If you put some vegetable pieces in it, what will happen? They will cooked. Again, many changes take places. So heat has changed in many states, right? Change in temperature, change in state of matter, and of course now we can do this expansion now, because you come to know that what is expansion, what is increasing of the volume. So in case of solid, what will happen? Take one thing. Take an experiment was given in your books, that one iron ball you are taking, beta, and you are hitting it, and take a gauze. You are hitting it vigorously, this and ball. What will happen? It is made up of iron. And after some time, what will happen? This ball will expand. How you can say it will expand? Because firstly, in the first step, what will happen when you are not heating it, what will happen? It will passes through it. It will passes through it. And after you start heating in second step, heat it. It will stick over here. And it will not go through it. It will not go through it. It will stick over here. Reason is this, because solid particles expand, intermolecular space between them has expanded, so it will not allow the ball to go through it. After some time, third step, wait for cooling it. Cool it. Again the molecules will get contract. First they will expand when we are heating it. Then again it's contract. The ball will go through it very easily. So this experiment shows that solid expand on heating, right, and cool on contracting. So this we have done. Next we'll do the liquids. Now we will do expansion in liquids. What happen in liquids, beta? The intermolecular space between the molecules are quite large in comparative to solid. Intermolecular space is between large. So when we heat it up, the intermolecular space between that is already larger will become more larger. They move randomly here and there, and then they collide with each other. The collision will occur. So that increases in the heat increases will increase in the liquid. The volume will increase. Okay, we'll take an experiment with this. See, in this experiment, we are taken a beaker. Water is kept inside it. Then we are heating it. What we are seeing inside this container that the water level first falls to B and then this rises steadily and reaches up to C. And the colored water expands on heating and demonstrating the thermal expansion in liquids. So this is the experiment through which we can tell that the expansion occurs in liquid. Okay. Now next, the expansions in gases. So what happened in gases, beta? The molecules in a gas is very far away from each other. Very far away from each other means intermolecular space between the molecules of the gases are large. And if we allow them to heat up, then they start moving randomly from here and there. When they start moving randomly here and there, the collision will occur. And definitely they will expand to the more volume. Right? They will run here and there. Like we will take an experiment with the balloon. We are taking a hot bath container, hot water in a container. After that, what we will do, we'll put a balloon inside it, on the mouth of that, and the vapors that get inside the balloon will allow the balloon to inflate. And because due to the increase of the level of air, volume will increase due to the heating molecules heating up. So it inflates, and this shows that when the volume inflates, means balloon inflates, the molecules are increased in number. That is increased due to we are heating the water. That means the heated water will increases the balloon level. Okay. Next expansion around us we can do, beta. Many expansions take place around us. We can take the example of beta bridge, iron bridge. You see that when the iron bridges are having the gap between them, little bit gap between them. Even you see on the roads, when the cemented roads are made, the very thin strip was left, a space is between them. Again, see the iron railings, where the railway tracks, I like to say, railway tracks, but we can see there is a gap between these tracks. Why these gap is there? Why? The reason behind this is, one common reason is thermal expansion. Thermal expansion of solids. Yes, in summers what will happen? The expansion occur in the solid. And if there is no gap between the railway tracks, then what will happen? The train will get a hump on it, and definitely the accident can occur. So there should be a gap after regular intervals, so that the gap can help the expansion. Same with the roads. For the long life of the roads, definitely after some regular intervals, they used to leave some space. Again, you can see on the walls, when we are putting the tiles, when the tiles are put, little gap was left between that. The reason behind this expansion, summers expansion occurs and winter again contraction occurs. For that, the gap should be there. Okay, the gap should be there, beta. Next topic I like to discuss with you is hot and cold. It's all about the relative temperature. Okay, there is an activity given related to this is, you can see hot water, cold water and ice water. A boy was putting his right hand, water in a cold, and then left hand tells the same water in cold. Why it is so? Because this is a sensation of touch that is relative. When your hand come from the hot water to warm water, you feel cold. And when your hand come from cold water to hot water or warm water, then you feel hot. The reason behind this is the sensation of the temperature, what we are feeling it. So this is related to our topic, that is temperature. Temperature has the SI unit Kelvin. You should remember this. And the definition I like to discuss is SI unit. I'll say this is Kelvin. Don't forget. It's important. And next definition, the degree of hotness or coolness of an object on some chosen scale is called its temperature. Okay. Yes, beta, we are on the temperature. We have done the unit. We have done the definition. Now, there are two gradings, and in that the fixed point, I can say lower fixed point and upper fixed point. Before starting that, I like to tell you three units are there: Celsius, Kelvin and centigrade. Okay, Fahrenheit scale, sorry. Okay, first is Celsius. In Celsius, fixed points, two fixed points are there: lower fixed point and upper fixed point. In the lower fixed point, 0 degrees Celsius is there. 100 divisions are there on the scale. 0 degrees Celsius is the lower fixed point. See beta, at 0 degrees Celsius, when we go to the minus 1, minus 2, at 0 degrees Celsius, water will start freezing. This is the freezing point also, and this is the melting point also. That means if we increases the temperature from 0 degrees Celsius, then what will happen? It will start melting. So 0 degrees Celsius is the lowest fixed point, and the upper fixed point is 100 degrees Celsius. Means as the 100 degrees Celsius comes, the water start boiling, right? The vaporization vapors start forming. Okay, so below it, its vapors start condensing, right? So 100 degrees Celsius is the upper fixed point in Celsius we are talking about. Now Fahrenheit we will talk. It is having 180 divisions, I'll tell you. Okay, lower fixed point 32 degree Fahrenheit and upper fixed point 212 degree Fahrenheit it is there. So it's having 180 divisions. A numerical is also there in your book regarding this. The formula is there. The formula is C upon 100 is equal to F minus 32 upon 180. When the values are given, you can put these values in this and you can take out the numerical very easily. So next topic we are going to cover about two types of thermometers. They are clinical and laboratory thermometers. So I'll draw the diagram. Okay, beta, this is the laboratory thermometer. In this thermometer, we are having the degree Celsius and degree Fahrenheit both. So its range is from minus 10 degrees Celsius to 110 degrees Celsius. Its range it is. Okay. So upper fixed point what we are having is 100 degrees Celsius or 110 degrees Celsius is the upper fixed point. That means mercury can rise up to that level. Okay. Lower fixed point, it is having 0 degrees Celsius to minus 10 degrees Celsius. That means it can decreases up to this level. So this capillary tubes containing mercury, as we dip it in the hot water or a hot body, we are hot water of course because the laboratory thermometer, and that mercury will rises and it can rises up to this upper level. And when we kept it in the cold water, the mercury will decreases up to the level that was lower fixed point. This is the laboratory thermometer used in the labs to identify the various temperature of the substances. We are doing experiments. Next we like to take is clinical thermometer. Next is clinical thermometer. You can see this is clinical thermometer. What is the main difference between this laboratory and clinical thermometer? Main difference is the stem. Yes, it is having a bend-like clink that prevents the movement of mercury back into the bulb when the thermometer is taken out of the person's mouth. And the range, it is having 2 Celsius and Fahrenheit again. Okay, so in the Celsius, 35 degrees Celsius is the lower fixed point and 42 degrees Celsius is the upper fixed point. Means above 42 degrees Celsius, it is not going to be reached. That is 98.6 in Fahrenheit. It will not exceed due to the clink is there in the clinical thermometer, means mercury will again come down. Okay, so this is all about the clinical thermometer. Various things that we should use to hold it. We should hold the thermometer firmly, which gives a few jerks and bring the level of the mercury below 35 degrees Celsius. Place the bulb of the thermometer under your tongue for 2 minutes. After 2 minutes, take out the thermometer, read the mercury level horizontally. You should read it horizontally, of course. And some thermometers are marked as Fahrenheit. So the ranges we all know, that is 94 degree Fahrenheit to 108 degree Fahrenheit, that should be there. Okay, so this is all about clinical thermometers, beta. Okay, so we have done with the thermometers. Just read them, understand them, and try to draw these diagrams also. If you are able to draw these thermometers, definitely it will help you to learn. So till then, thank you. Have a nice day.